Hello, today we're looking at simultaneous equations. We've got two lines, they've been drawn over here. The green line shows us 3x plus y equals 6 and our blue line shows us 2x minus y equals minus 1. We don't need to graph them to solve simultaneous equations, but it's just nice to see it when we're learning about it. So we want to solve this. It's very easy, thankfully. And we can already see our answer. Our solution is already here in the diagram, 1, 3. But like I said, we don't need to draw them. But let's just work through the solution. So the first thing we're going to do is going to total up our equations. I say total because here it's plus 3 and plus 2. So that's plus 5x. That's adding because they're both plus. Here I have a plus and a minus, so it's kind of subtracting here. Plus 1y, take away 1y, gives me 0 y's. And plus 6 take away minus 1 is plus 5. I want to highlight that 0y, because that really is the key to simplifying this problem. The plus 1y and the minus 1y give us 0y. So our problem now is much easier. You can see now our problem is 5x equals 5. That's a lot simpler than this line or this line. It's certainly a lot easier than having two lines together. This is nice and easy to solve. So here we can divide both sides by 5 and we get our answer x equals 1. If you want, you can say 1x equals 1. And if you want, you can show your work. You can show it by drawing fractions. We're dividing both sides by 5. Some people prefer not to show anything. And some people might prefer to write it like this, to show that they're dividing both sides by 5. And the reason this works is because 5 divided by 5 gives you 1x. We want to know what 1x is. So as usual, I like to highlight these things, the 0y and the 1x, I like to highlight those in red. You'll see that in our equation, our video on simple equations. So if any of this seems tricky, pause the video and look at our video on simple equations first. It will make it easier. So like I said, we don't really need to show all this. We don't need to show the dividing by 5. And sometimes it just makes it look a little bit more complicated. We don't need to show the red 1. That's 1x, means the same thing as 1x. So we can go on now using this x, x equals 1. So we'll take our first equation, our 3x plus 1y equals 6. We're going to get rid of x. So what's going to go in there for x? What's going to go in here? We know that x is 1. So 1 goes in here. So this was 3 multiplied by an unknown number. But now we know what x is. So it's now 3 multiplied by 1. 3 by 1 is 3 plus y equals 6. So again, we should be able to solve this easy. Take 3 from both sides. Y is equal to 3. If we want to show that, we can. Again, you don't need to, but taking 3 from both sides. 3 take away 3 is 0, 6 take away 3 is 3. And if we are showing it, it is nice to write down again, you're getting 0 here. So it's 0 plus y. Or we could write down 0 in words if we want to remind ourselves. Again, we want to try and keep this simple. We want to look at simultaneous equations. We don't really want to be focusing too much on how to do the same thing to both sides. We learned that before in our video on simple equations. However, this idea here, these zeros, is really what makes solving simultaneous equations very easy. We'll look at that a lot in a moment. For now, let's just take it away and remind ourselves how easy this was to do. All we had to do was total up the equations. 3x and 2x gives us 5x. 1y take away 1y is 0. 6 take away 1 is 5. And the problem was so much easier now. 5x equals 5. That's so easy. We can divide both sides by 5 to get x. And then we can put this value back in for x. call it substitution. So we're getting rid of our x, we're substituting in number 1 here, and working through it to find our solutions. So our solutions are x is 1, y is 3. So our x, y is 1, 3. Just like in our graph. So we could see the solution from the very start, and we can confirm that that's the correct solution. Hope you found that very easy. What we're going to do now is we're going to go and look at some very similar problems. They can get a little harder, but all the basic ideas are here. So for a little bit of practice, it might get you to just total up equations, just like this step here. See, can you do that? Now we're going to pull up some similar equations, give you a little bit of practice. So total those up just like this. Let's see what you're getting. You can pause the video once we put them up here. So again, we've got just 2 to practice. We're just trying to do this step here. Okay, so hopefully you've had a go at this one and this one. Let's see, adding our x's, we get 6x. We're adding them because they're both plus. Here we've got different signs, so we're subtracting. 3 take away 3, that's 0. Here we've got the same sign, so we're adding again. 7 and 5 is 12. So again, this is a lot easier than what was going before. We could easily solve that. Divide both sides by 6, and we'll find x is equal to 2. Looking at this one, 4x take away 4x, that's 0 x's. 2y plus 3y is 5y. And 8 plus 7 is 15. And again, look how easy this is. This is something we can easily solve. Divide both sides by 5, and we'll get our answer, y equals 3. So here we'd get y equals 3, and over here we were saying we would get x equals 2. So hopefully if we can understand this step here, the next part will be very easy to understand too. We're going to look at when it just gets a little more complicated. So we said we'd look at a slightly trickier problem. So I've drawn 2 graphs here. The first line is shown in black, and our second line is shown in blue. And we can see they're touching each other or intersecting at 6, 1. So we already know the answer should be 6, 1. Our solution should be 6, 1. Let's try the same technique as we did with our last pair of equations. They're both plus, so we're adding 1x and 1x, that's going to give me 2x. Minus 2y and minus 5y. Well, if I lost 2 and I lose another 5, I've lost 7. And plus 4 and plus 1 makes 5. We can see we have a problem here. This didn't get any easier, didn't get any simpler. So why has this failed? This technique worked last time. So we're going to take a little look at why this is failing and what we might do about it. And we'll find that while this looks tricky initially, it's just as easy as the last problem. So let's take a little look at a few problems similar to this, some that don't work and some that do work. A moment ago we saw this wasn't working, but we could see in the graph that the solution should be 6, 1. So we're going to take a look at 2 equations here that are very similar to this. We can see that we've got 1x here, a minus 1x, minus 2y, plus 2y, and plus 4 is a minus 4. So all 3 signs have changed. And same again, all 3 signs have changed. I'm sorry, I'm missing a minus here. So all 3 signs have changed. So will this make the problem any easier? Let's see. So totaling these up, minus 1 minus another 1, so it's minus 2x. It's like you lost 1, you lost another 1, you've lost 2. plus 2 and plus 5, that's 7y, minus 4, minus 1, minus 5. So that didn't get any simpler either. So changing all the signs didn't help at all. If you look here in the last one, we've left this unchanged, so it's still plus 1x minus 2y and equals 4. So that hasn't changed at all. But we have gone with this equation. So again, we could say that we changed all of these signs. Will the problem get any easier now? So 1x minus 1x, that's 0 x's. Minus 2y plus 5y, 3y. And on the right hand side of the equation, the plus 4 and the minus 1 gives us plus 3. So that's a lot easier because we've got 0 x's. So if you go back to the video a few minutes ago, it worked because we've got 0 y's. Here we're getting 0 x's and it's simplified. I can solve this quite easy. Divide both sides by 3 and I get y is equal to 1. That's the solution we know we should be getting. If we substitute the 1 back into our first equation, that would be x minus 2y, so x minus 2y equals 4. So what's going in for y? What's y being replaced with? Being replaced with 1. So it's minus 2 multiplying by 1. That's just minus 2. I can solve this now by adding 2 to both sides. I get x equals 6. Again, the solution we know we should be getting. So you can see our problem wasn't very difficult. Once we arranged things to suit ourselves, we needed to get that 0 x's. That was the key. That simplified the problem. Having a plus 1x and a plus 1x didn't help. Having a minus 1x and a minus 1x didn't help. But having a plus 1x and a minus 1x, that was great. That gave us 0 x's. So we just need to make sure that we arrange our equations so that we get plus 1x minus 1x, or indeed could be plus 3x and minus 3x. We just need the situation that will give us 0 x's or 0 y's. Getting rid of either the x's or the y's, we call it eliminating. Here the x's have been eliminated. So we want to eliminate one of our variables. So we're left with something nice and simple. We see that the key thing is the 0 x's, but we kind of glossed over how all these signs changed. So we glossed over how all these signs changed. We want to take a look at that to make sure we understand what's happened there. So we'll rub off a little bit of our work. We'll just make a bit of space. And as well as that, we're going to label our equations. So we're going to label this equation equation 1. I'm going to label this equation number 2. That just lets us follow what's happening a little bit easier. We saw that equation 1 didn't change at all. So again, just using those labels, I call that equation 1, call that one equation 2. So what did happen though? What happened to equation 2? All the signs changed. And how can we change the signs of something in maths? It's very simple. All we need to do is multiply by maybe minus 1. So we can show it maybe by writing it here or here. We're just multiplying by minus 1. Sometimes I like to put the minus 1 in a little circle. So again, it's showing what's happening in blue. So this minus 1 has to multiply everything on the left hand side. It also has to multiply everything on the right hand side. So it's multiplying the left side and the right side. So let's take a look at that. Minus 1 multiplying x minus 5y. That's what's happening on the left side of the equation. And on the right hand side of the equation, we're multiplying the 1 by minus 1. So everything we had already is still there. What we're doing to both sides has been shown in blue. Maybe we'll just change the colours of that to really highlight the point. Our equation was x minus 5y is equal to 1. So what have we done to both sides? We have multiplied both sides by minus 1. And we do this just because it's going to make our life easier. It's going to give us the plus 1x and the minus 1x, which is going to give us 0x. So minus 1 by plus 1x, that's minus x, minus 1 by minus 5y is plus 5y. It's very important we know our signs for multiplication. Minus 1 by plus 1 is minus 1. If we're a little unsure on that, what's happening, we're just making sure that the minus 1 multiplies both terms. So the first multiplication, minus 1 by x, is minus 1x. The second multiplication, minus 1 by minus 5y, gives us plus 5y. You can see we're not multiplying the left hand side more than the right hand side. Remember, we're only multiplying once on both sides. It just so happens that there's already two terms there, so you have two little pieces of work to do. But you're multiplying both sides by minus 1. And this gives us the equation we have here. So we'll take a little look at more of these, and we'll take a look using the lowest common multiple.